Okay, so we're looking at these notes right here, percent yield notes. So we know in a basic stoichiometry problem, only one is given. In a limited reactor, we have two givens and a percent yield. It will say what is the percent yield. Percent yield is the efficiency of the reaction. So we're going to have our actual yield and our theoretical yield. Don't walk in front. An actual yield is what's actually produced in the lab, whereas a theoretical is what's produced how? How is it calculated? Stoichiometry problem. All right, so read the first one. Read right here. When 4.58 grams, that's a terrible color. 45.8, we know. Same thing. So when 45.8 grams of what? Potassium carbonate reacts with all right, the other products. So if we do a basic double replacement, K goes with Cl, H goes with CO3, we get carbonic acid. But carbonic acid immediately breaks down into water plus carbon dioxide. That's why it says the other products are water and carbon dioxide. So a couple of things real quick. Notice how I've always labeled above. So, okay, so if you notice on your sheet, what's our formula for percent yield? Actual, right, and that's why I taught y'all to write above, because actual divided by theoretical. So we're going to put a question mark grams. Why did I put question mark grams here? Because my actual is in grams. Okay? All right, so A over T. Okay, so we got to balance this sucker. We got two potassiums here, two potassiums there. We have two hydrogens here, two hydrogens here, two chlorines, three oxygens, so it's balanced. All right, so how do we start a basic stoichiometry problem? We always write the given. So 45.8 grams of K2CO3. Why am I starting with 45.8? I like what you're thinking. What does the word yield mean? Percent yield. What does yield mean? Produce. You're in driver's ed. I like it. Driver's ed students are always like, go slower. No, remember the arrow means yield or produce, right? And so we're always going to be given a product value, and that's going to be our actual. So whatever our reactant is going to be. Okay? So the words on the top are the words on the bottom. So grams of K2CO3 is equal to 1 mole of K2CO3. What's the molar mass of potassium carbonate? So potassiums, there's two of them times 39.10. Carbon, there's one of them times 12.01. Oxygen, there's three of them times 16. And what is the answer to that? Because that's how we get to the words on the top or the words on the bottom. That's molar mass. That's our conversion. Okay. What is the molar mass of K2CO3? 138 point what? Did I get 138.2? What did you get? 138.2. Because that's the molar mass. That's our conversion. So the next step, first step get to moles. Second step is what? Mole ratio. So the words on the top are the words on the bottom. So K2CO3, we go to our balanced equation. There's 1 mole of K2CO3 for every 2 moles of KCl. Right? Now we got one more step. First step, get to moles. Second step, mole ratio. Third step is get back to grams. So for every 1 mole of KCl, it is grams of KCl. So 39.10 plus 35.45. 74.55. Is that what y'all got? All right. So multiply across the top, divide by the denominators. 45.8 times 2 times 74.55, enter, divided by 138.2. My calculator's all messed up. 49.41. So we're going to erase that and put 49.55. Is that what you told me? 49.4. Tell me, baby, what stuff is that? Right. So how do we do that? Right. Molar mass conversion. Good. All right, so we multiply across the top, divide by the bottom, we got 49.4. So now we're going to check ourselves. The theoretical is always what compared to the actual? It's always greater, right? Yeah, actual is never greater than theoretical. I asked it backwards. So theoretical is always greater, so we might have it right. We most likely do. So go ahead and divide that, and turn it into a percent. Tell me what you get. That's why we have it like this. A divided by T. That's why you went out, you left during class. You don't have to watch the video. 93.7? So it'll be 93.7%. All right, so that's our percent yield. That's it.
So fun.
I know, right? Let's do problem number 2. It says aluminum carbonate, so chlorate, decomposes. So we know a metal chlorate decomposes into a metal chloride plus oxygen
gas.
Excellent. So read the problem to me. With 5.45 grams.
1.57 liters.
So 1.57 liters. This is my actual. I'm going to need my theoretical. And what would be my units for my theoretical? Liters, right? So it says liters. Let me get the glare off of that. Oh, well. Hope y'all can see this. We're trying to make it where you can see that. Oh, you're there. So, there's a bad glare. All right, so we're going to start by writing the yikes, yikes, I have 2 givens. Not necessarily the smaller one, I have to use this one, my reactor one. And you're right, I need to balance that sucker real quick. So I have to distribute this. So that's going to give me 3 and 9. So I have 3 chlorines, but I'll have to put a 9 here and double all my coefficients, right? So we start by writing the given 5.45 grams of aluminum chlorate. Remember, we always need a number, a unit, and a formula. So the words on the top are the words on the bottom. So grams of aluminum chlorate. So aluminum, what is aluminum again? What's the? Yeah, I know this is 277.3, but what's the molar mass of aluminum?
26.98.
All right, so we add all that up together and we get 277.3 grams is equal to 1 mole. Because the first step is get to moles, right? Got to moles. Second step, mole ratio. Where do we get those numbers from? The coefficients from the balanced equation. That's why it's super important to always balance. It's always unknown over given. So 2 moles of aluminum chlorate over 9 moles of oxygen. All right. So moles of aluminum chlorate cancel. The words on the top are the words on the bottom. So for every 1 mole of oxygen, there is going to be how many liters of oxygen? 22.4, because that's our conversion. Multiply across the top, divide by the denominator, what do you get? 1.98 liters. So we erase our question mark. We put 1.98 liters So this is our actual, our theoretical. We calculated, and what do we get? 79.2%. 0.3%. All right. We have three decimal places, so it's balanced. All right. Y'all do the next problems on your worksheet.